everyone, so just a reminder that we are starting this class with a couple units of Algebra 2 and then we're going to jump into the geometry. So prepare yourself for a little bit of algebra. We're going to start today with some stuff that should be mostly review, and then we'll get into some new stuff later on. As a bit of a warm-up, go ahead and take a look at each of these expressions here, and which of these do you think is a polynomial? So if you want to pause the video and think about that.
Caleb Litz, your bus is waiting. Caleb Litz, your bus is waiting.
I don't feel like starting this over, so just skip over all the announcements. All right, so hopefully you've had some time to think. Which of those you think is a polynomial? And so the answer is there's actually two. This one is a polynomial, and this one is a polynomial. Just want to refresh a little bit of vocabulary, and we'll come back to this in just a second. So just a little vocab review. A term. A term is a number. It could be a variable, or it could be a number and a variable. So if I have something like 2x plus 5 minus 3y. 2x is a term, 5 is a term, negative 3y is a term. They're separated by this plus and this minus. So anytime you have plus and minus, they separate the terms.
Caleb Litz, if you're in the building, this is the last call for your bus. Caleb Litz, if you're in the building, this is the last call for your bus.
A polynomial literally means, the prefix poly means many, and nomial means number, in this case term. So it literally means many terms. A polynomial really just means one or more, which is kind of lame, but a polynomial includes binomials, which is bi is 2, so 2 terms, trinomials, which are 3 terms, and then here's some examples. So like 2x plus 3, 2x and 3 are 2 terms. X to the 5th is a term because it's x times x times x times x times x, so that's all one term. And then the minus 1 is a term, so that is a binomial as well. This one has 3 terms, so it's a trinomial. And then we have, last year talked about like terms, which literally just means terms that are alike. To be like terms, they have to have the exact same variables with the exact same exponents on those variables. For example, 2x and 3x. Those are like terms. They have the same variable, both with an exponent of 1. Or if I had 2x squared and 3x squared. Those are like terms because they're both x squareds. But if this one has a y in it as well, they're no longer like terms. Or if this one does have a y, now they are like terms. I could add them together, and when you add like terms or subtract like terms, basically think of like 2x plus 3x as like adding 2 apples plus 3 apples means you have 5 apples kinds of things. The x part is going to stay the same, but I'll add 2 plus 3, which gives me 5 of those x's. Same thing here, even though it looks complicated, if I have 2 of these x squared y's plus 3 of these x squared y's, that would give me 5 x squared y. The variables won't change, just the coefficient in front. None of these are like terms because that's just a constant. That one has an x and that one has an x squared. They don't have the same exponents, so they're not like terms. So let's go back to this right here. A polynomial is just a combination of many terms. So it can be any sort of combination of addition or subtraction with different terms. So here's a term and all these different terms. It's just numbers and then multiplication and then adding or subtracting those together. This one is also just a binomial. Here's a term, here's a term. Here's a few things that doesn't count as a polynomial. Anytime you have an exponential function where a variable is actually an exponent, that's not a polynomial. Anytime you have a square root, that's a radical function, so not a polynomial. And anytime you actually divide by a variable, like this or this, those are not considered polynomials. So there's some exceptions, but anytime it's just a combination of some terms, that's a polynomial. This unit is all about working with polynomials. That's why I wanted to do some review. We're going to go through a few examples of operations with polynomials. Operations is like the verb of math. That just means you're going to do something, like add, subtract, multiply, divide. There are others, but those are the main four. So we're going to look today at adding, subtracting, and multiplying polynomials. All really should be reviewed to you. All right, so for our first example, I want to add up these two polynomials. Really, you could just replace that and with like a plus sign. If you want to put parentheses around those, you can, but it's not really going to matter. All I need to do to add polynomials is combine like terms. Again, this should look pretty familiar to you. To add polynomials, if you have any like terms, you add them up. So like negative 5x and 3x would combine to make negative 2x. None of the rest of these are like terms, so they'll stay as they are. And that's my final answer. Here's another addition of two polynomials, but again, since there's nothing in front of the parentheses, I don't really need those parentheses. They're kind of unimportant. Again, I'm just going to look for like terms and add those together. I noticed that 4m and 6m are like terms, and also 12m cubed and negative 3m cubed. I think that's it. It's helpful when you work with polynomials to get in the habit of putting the highest exponent first. We call that the degree of the function. We'll talk more about that later, but I'm going to put the cubed stuff, then the squared, then the m's, and then the constant at the end. You'll see later why this is helpful. So 12 minus 3 would make 9m cubed. Then I like to mark them off once I use them so I don't get confused. Then 11m squared. Then 4m minus 6m would be negative 2m. And then plus 1. There we go. See how it's in like descending order? Which is kind of helpful. So that's my final answer. Let's get into some subtraction. It's pretty similar to adding, just one little extra step. Before each of these examples, you should pause and try it yourself first. So go ahead and try this problem, and now we're going to go over it. This one is a little confusing because it says subtract this from this. Like if I were going to subtract 2 from 3, I would actually flip the order and do 3 minus 2. So in this case, you're not going to do this minus this, you're going to subtract this from that, meaning you'll need to start with this one. I'm going to subtract this whole thing. All right, what I've written right now is actually incorrect. I need to subtract this entire polynomial, not just the first term. So you'll probably want to use parentheses to indicate you're going to subtract the entire thing. You can put this one in parentheses too if you want, but there's nothing in front, so you don't need to. The reason that's important is if I'm going to subtract this entire polynomial, I need to distribute this negative to every single one of those terms. I'm subtracting this, and I'm subtracting this. Basically, this is a negative 1, and you're distributing that negative 1 out to each of those terms. So let's do that. Negative 1 times this is negative 3x to the 5th. If I do negative 2, that's positive 2x squared, and negative 1 times 1 is negative 1. Now this all can just combine with these original terms that we had. 8x to the 4th plus 9x squared. Now we're just adding, so we'll do what we did before and just combine like terms. Let's start with the highest exponent. So negative 3x to the 5th is by itself. 8x to the 4th is by itself. I've got 9x squared plus 2x squared, so 11x squared, and minus 1. That's my final answer. Here's one more subtraction problem. Again, pause it, try it, and then you can watch this explanation. This one's already written out for me, so that's nice. But again, this negative needs to be distributed to everything after it. If there was like a plus 1 here, it wouldn't need to be distributed there, but to at least everything in the parentheses. So distribute that negative 1 to each of these. It's just going to make them a negative. It'll make this negative 1, positive 6m, negative 11m squared, and negative is positive 3m cubed. This will stay the same. And now I'll just combine like terms as we did before. I've got 12 plus 3, so 15m cubed. I've got minus 11m squared. 4 plus 6 is 10m. And then a minus 1. Last, we're going to talk about multiplication. So we did add, subtract, and now multiply. Remember, anytime you multiply this kind of stuff, you really need to distribute. If w and 6 were like terms, I would just combine them because they're in parentheses. But I can't because they're not like terms. So the way we handle that is this negative 4w will just distribute, just like we did the negative, to everything in the parentheses. And we're multiplying here because they're written right next to each other. So if I have w times w, that is w squared and negative 4w squared. And then negative 4w times 6. First of all, negative 4 times 6 would be negative 24. And there was a w as part of that, so we'll leave the w. That's my final answer. Here's one more example. If I want to multiply these two polynomials together, another way to write that would be like this. Multiplication, because they're written right next to each other. Don't combine like terms here, you need to distribute. And not only do you need to distribute the negative 5x, but you also need to distribute the x squared. Some people call this FOIL. So I'll take the x squared times that, and times this, do that, times the 3x, and times the 10. So make sure you follow each of these arrows. X squared times 3x is 3x cubed. X squared times 10 is 10x squared. Negative 5x times 3x is negative 15, and x times x is x squared. And then negative 5x times 10 would be negative 10x. If you ever have like terms at the end, you will want to combine those. So these two are like terms. 10 minus 15 makes negative 5x squared. Everything else stays the same. And that's my final answer. I won't make you do this whole problem, but I just want to show you that the whole distributing thing works no matter how many terms you have. So like on a problem like this, a trinomial times a trinomial, I would need to distribute this to every term over there. I would need to distribute this to every term over there. And I would need to distribute the 1 to every term over there. I would end up with like 9 terms that I would have to add together. We won't go through that, but just wanted to show you that you can if you want to. All right, I feel like you guys have this down because we've done it in the past, but if you feel like you need some extra practice with this, I'm gonna put some optional practice for these operations with polynomials. We're also gonna get to division a little later on, so hang tight for division. We haven't done that before, but we're gonna do some other stuff first. So if you feel like you need extra practice, you could do it. If not, I feel like you're just good with these examples. If you feel good to go, I'm okay with that.